The previous examples that we've looked at have all been scenarios where we don't have a multiplier in front of our x squared term, so that no a value. Okay, when a is not 1, when we do have a number out there multiplying, we still will complete the square. We just have to be a little bit more conscious, and there's going to be one additional step that we need to take. So step 1, always, you can check for factors. Be like, is there any way I can do this? So negative 2x and x and like 7 and 1 or 1 and 7. There's no way I can factor this, unfortunately, to get 3 as my middle term. So again, I'm in a situation where I need to complete my square. So I take out that negative 2, and it leaves me with x squared plus 3 halves x plus 7 equals 0. Again, I'm going to take half of that. So that's going to be 3/4 squared is going to be 9/16. I'm actually taking 2 9/16 away. So I'm going to add 2 9/16 here. So that's 18/16. Or if you want to think about it as being reduced, it's going to be 9/8. Okay. From here, we're dealing with fractions, which I know is sometimes an uncomfortable space. If you plan on continuing beyond high school, especially with math, then I definitely recommend that you try and work with fractions to the best of your abilities. If you're thinking, once I'm done with pre-cal in grade 12, I'm probably not going to take any more math after that, then you've got a little bit more wiggle room to try and use your calculator. But I would recommend trying without first. So if we simplify this, everything that we've got written, we've got x plus 3/4 squared plus, and I'm going to do a little scratch math over here, 7 turns into 14, or not even 14. I want to get it as eighths, so that's going to be 56. Yes, 56 eighths. We're going to add 9/8. Sorry, I always mess up my 7 times 8 piece. Don't know why. I've got a mental block there. Okay, plus 9 is going to be 65 eighths. So that's what I'm going to be working with fraction-wise. 65 eighths equals 0. I'm going to move this fraction onto the other side. So I've got minus 2 x plus 3/4 squared equals negative 65 eighths. I'm then going to divide by that negative 2. I want to get rid of that coefficient now. So I'm left with x plus 3/4 squared equals, and so this is like I'm multiplying by 1/2 is another way of thinking about it. So this is going to turn into 65/16. Okay. From here, I take the square root. This is a bigger process. So I've got x plus 3/4 is going to give me plus or minus the square root of 65/16. Now, because 16 is a perfect square, you can rewrite this to be the root of 65/4. You're more than welcome to do that. You do not have to, but you can. Okay, from here, and the reason that I would be inclined to do that is what happens next. I need to move this 3/4 onto the other side. And because it's a common denominator, how I'll be able to write it is negative 3 plus or minus the square root of 65 all over one common denominator. Okay, if you didn't do this part and you stopped here, then your final answer would be negative 3 plus or minus the square root of 65/16, all under that square root symbol. Okay, either one is fine. You're then going to check. Again, using your calculator is definitely the way to go on this one. You will not have extraneous roots though, probably. Just double check to make sure. So let's try it again. If you want to pause the video even just for the completing the square part, that's not a bad idea, just to make sure we've really mastered that skill. So pause the video right now, try to just complete the square on your own. Okay, so again, we factor out that -5, factor out that value multiplying by x squared. Plus 2x is what we're left with. Plus 2 equals 0. Half of 2 is 1, squared is 1, but really I'm subtracting 5 ones, so I'm going to add 5 on the outside here as well. From here I'm going to simplify. X plus 1 squared plus 7 equals 0. So that's going to be, and I'm going to skip a step here, x plus 1 squared equals -7, but then divided by -5 is going to be +7/5. Okay, so that's moving the 7 over and then dividing by -5. From here, we're going to square root both sides. And I end up with x plus 1 equals positive or negative square root of 7/5. Now, unfortunately, neither of those are perfect squares, so unlike the previous question, I'm not going to be able to simplify. Then I must subtract 1 from both sides. So final answer is x is -1 plus or minus the square root of 7/5. And once again, you will want to check by plugging into your calculator. Okay, so here we go. Some funky stuff going on here. When you're dealing with a fraction, what is the one thing that we know about fractions? We don't like them. So, to get rid of a denominator, how do we cancel out something that we're dividing? We multiply. Because this is an equation, I'm allowed to do that. Because what I'm going to do is I'm going to multiply everything on both sides by that amount. So everything over here times 2, everything on the right side multiplied by 2. Now why this works particularly nicely is because this side is 0, so it actually won't change. So it will still allow me to solve for x. So I'm left with x squared plus 6x minus 9 equals 0. Well, this is actually a factorable equation. Actually, it isn't. Sorry. It looks like a perfect square except for this negative sign. Okay, so because it's not factorable, my only other tool right now is that I have to use my completing the square strategy. So, but we've turned this into an equation that doesn't have an a value, so it's kind of nice in that sense. So I've got x squared plus 6x minus 9 equals 0. Well, half of 6 is 3, squared is positive 9, so I'm going to subtract another 9 out here. So that leaves me with x, plus 3 squared minus 18 equals 0. So x plus 3 squared is 18. Take the square root of both sides. X plus 3 equals, you can either leave it as the square root of 18 or you can write it as plus or minus 3 root 2. Okay, we're calling that root 18 can be broken up into root 9 and root 2. Okay, from here we got to move that 3 still. So x equals, I'm finally left with the -3 plus or minus 3 root 2. And once again, we have to check. Again, because we're dealing with radicals, you're more than welcome to plug it into your calculator. Same thing goes for f. Because we're dealing with a fraction, definitely just multiply to get rid of that denominator. You could even go so far as to get rid of that negative as well. If I multiply by -2, then I'm essentially canceling out that negative because negative times a negative is a positive, and I'm getting rid of that denominator. So kill two birds with one stone there, metaphorically. Leaves me with x squared negative 12x and a positive 2 equals 0. Again, this is not factorable, so my only strategy left is to complete the square. X squared minus 12x plus 2 equals 0. Half of negative 12 is -6. Squared is positive 36. So I'm going to subtract 36 out here, leaving me with x minus 6 squared minus 34. Again, isolating my squared term is the next step. And then taking the square root. Plus or minus the root of 34. And there are no perfect squares that go into that one, I don't believe. Nope. So we'll leave it as that. And our final answer will be 6 plus or minus the square root of 34. But you are not done until you have checked your answer using a calculator. If I'm not mistaken, oh, we got a couple more, but this is our last part of this example. We're dealing with 3x squared plus 9x plus 5. Again, this is not factorable, so I have to complete the square. X squared plus 3x plus 5. So 3 divided by 2 squared is going to give me 9/4. I'm adding actually 3 times 9/4, so I'm going to have to subtract. 3 times 9 is 27/4. So again, dealing with fractions, not our super favorite thing to do, but we can accept that. So we've got 3x plus 3/2 squared, and then 5, just again working over here to work with those fractions. 5 turns into 20/4. Minus 27/4 would be -7/4. Finally working. Again, from here our steps are still the same. Even though we're dealing with fractions, even though we're dealing with multiplication, it's still the same values. It's still the same steps that we're doing. So 3x plus 3/2 squared equals 7/4. We're going to divide by 3 first. So x plus 3/2 squared. So we're getting our squared term completely isolated. Gives me 7/12. Take the square root of both sides. Again, you do not have to simplify any of this, but you can. So you're either going to be dealing with plus or minus the square root of 7/12, or you could be dealing with plus or minus root 7 over 2√3. Okay, either one is totally fine. Where that denominator is coming from is the fact that 12 can be broken down into √4 and √3. And this can be simplified to 2. Okay, from here we need to move that 3/2 still. So we're dealing with negative 3/2 plus or minus root 7/12, or again, negative 3/2 plus or minus root 7 over 2√3. So either way, totally fine, as long as we end up with one of these two pieces as our answers and we check them. Okay.